Hey, and welcome back. This is the second Kerf Screencast, and we're going to go over stock basic stats, which means we're going to do something slightly more advanced than the most basic stuff that we did in the last screencast. We're going to show you a lot of queries today, but if you want a heads up on what the highlights are, they're as follows. We're going to build a stats table, which means that we're going to do some pre-computations to get some derived values from the basic stock data. And the reason that we'll do this is it will be useful for computing things down the road. We'll also take a look at how to generate a list of all the stocks that closed up for the day and how to find out which was the stock that closed highest from the start. The final highlight that's worth noting is that we'll see which stock was traded heaviest for a variety of definitions of heaviest. If you have any questions, I'm Kevin at getkerf.com, and the sample file, if you want to follow along, is at the URL shown. This is our terminal session from the last screencast. I've just punched in a bunch of new lines here. To start, we'll generate that stats table that I mentioned earlier. And this is a big long query, or it looks like one, so let me break it down for you. The first column is we're going to take the first price from the prices column, and we're going to call that the open. Then we're going to do the same thing with the last price and call it the close. Then we're going to take the close, subtract the open, and call that change. And what the change is just the change in stock price over the course of the day. The final column there is the VWAP, or volume weighted average price. And if you're unsure on what that is, you can refer to the previous screencast. The most important bit is the group by sim clause at the end there. And what that does is perform all of the previous four operations on every group of rows separated by symbol. So we get all of the stats on a per symbol basis. You can see that the symbols are displayed in a slightly odd format. They should be dot delimited between the symbol subsections, but we'll ignore that for now. What's important is that the open, close, change, and VWAP for each symbol are present in the table. Before I show you the nice way to calculate the stock that gained the most using our nice stats table, I'll show you a slightly tougher way using some data we generated in the first screencast. This is data left over from the last screencast, the opens table and the closes table, which contain the opening and closing prices for each symbol. What we're doing in this statement that you see is taking the price column from opens and subtracting it from the price column and closes, and that's going to give us all of the changes. We'll store this in the variable diffs. There's a semicolon at the end of this statement which separates this first statement from the following one. The next one is a SQL statement, and we're going to select directly from the closes statement where the items in the diffs variable that we generated are equal to the max value that's present in that diffs column. In Kerf, the columns are ordered and the correspondences are preserved. So what you're seeing is a fancy way in SQL to return the row from closes where the symbol is the symbol that actually has the maximum change for the day. In other words, AAMC is the stock that gained the most over the day, so that was one you really wanted to be holding. And then what's shown is its closing price. If we grab the maximum value from the diffs variable, it should be the same as the value for the change column that we see in the stats table corresponding to the symbol AAMC. That query that we just ran queried the stats table directly. And if you notice, the SQL is a bit shorter and a bit easier to read, though it's giving us the same result back. And that's, in a way, the power of using the stats table, is that you don't have to run the computations over again. And it's kind of a shorthand way to reference things. Now let's try the same thing, except we'll use the stats table directly to find out which stock lost the most over the course of the day in absolute terms. Somewhat to our surprise, it was Warren Buffett's holding company, Berkshire Hathaway. These are Berkshire preferred shares. And the reason it surprises us is that Buffett's a good investor, and so why did he lose so much? And the answer is that Berkshire A shares are extremely highly priced. So in absolute terms, if you have a very high stock price, then you also stand to lose a lot of points on any given day. So maybe looking at prices in absolute terms is not quite what we want to do. It might make more sense for this investigation to look at something that's based on a percentage. We can do that easily enough, and one way to do it is to look at the change in the stock price relative to the open, which we can accomplish here by simply dividing the change by the open. This value, change over open, we could refer to as growth. And so in your head, you can substitute change over open in this query for growth, and then it reads select from stats where growth is equal to the minimum growth. And it's of course possible to have negative growth. If we want, we can turn this into a table by selecting the symbol column and then the change over open values and calling that growth. Because we have the stats table, this computation is actually rather nice. The SQL statement is very short and easy to read. So let's take a look at how complicated it would be if we had to do this from first principles. This statement gives us the same growth table as before, but as you can see, instead of leveraging the shorthand that the stats table provides, we have to rederive all of the opening and closing prices and nest that in the SQL, and it becomes much more difficult to read. Let's step away from growth for a minute and ask which stocks gained over the day. That is, which stocks closed higher than they opened. And using the stats table, there's another shorthand way to do that, which is to just select the rows where the change is positive. Let's take a look at another kind of way that a stock can end the day closing up. So as we just looked at, you can have a closing price that's higher than your opening price, but you can also have a closing price that's higher than your average price during the day. Let's dig in to get a sense here of how to think about some of these operations purely in terms of vector operations. So you can see in this statement, we're taking the closes.price column, or vector rather, from the table and comparing it directly to the stats.vwap vector from the stats table. The comparison operator in the middle, the greater than, is going to take each of these arrays and compare them on an item by item basis and return an array of the same length which contains only zeros and ones. In this case, the zeros represent rows where the closing price failed to be greater than the VWAP price, and the ones represent rows where that comparison operator held. Put it another way, we get a vector of Boolean truth values, and if we pass that to a where specification in a SQL statement, we can get the select statement to select only the rows where the truth values hold. Here's a really advanced alternative form of what we're doing if you want something to play around with. Using our stats table, the close higher than VWAP calculation is easy to perform. Let's try two more queries. The first query will tell us which stock had the highest volume, that is, which stock had the most shares change hands. To do this, we'll use a nested SQL statement. In the nested SQL statement, we build a table that contains the sum of all shares traded for each symbol. In the outer SQL statement, we're selecting from these summed volumes to find where the max volume is using the trick we explained earlier. One more query. We'll do something similar to the last query where we use a nested subquery to find another maximum value. In this case, instead of finding the highest volume over the day, we'll find the highest dollar volume, that is, which security caused the most dollars to change hands. We can see that it was SPY, which is a popular index fund for the S&P 500. If you have any questions, I'm Kevin, and you can contact me at kevin@getkerf.com. If you want the sample file that we used during the screencast, then navigate to bit.ly/tac-sample.